Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 5.3, adding and subtracting with like denominators. The steps for adding and subtracting with like denominators is we will add or subtract the numerators. We're going to leave the denominators the same or leave them alone. At that point, once we have added the numerators and we have left the denominators alone, we are going to factor if necessary. You may need to simplify after you factor, and we need to list any restrictions if we have any. Okay? So basically, after we add or subtract the numerators, it's going to turn into our last unit all over again. So let's look at problem number 1. Because our denominators are the same, we can go ahead and add this x and this 3x. Well, x plus 3x would get me 4x. 2 minus 2, or 2 plus negative 2, will get me 0. So those would actually cancel out. Now our denominator, we want to leave it alone. Since it is x in both, it will be x again in our answer. Now we're going to check and see if we can factor 4x and x. There's nothing we can factor. But looking at this, our next step here, 4x over x, this is exactly like our previous unit. So I need to state my restriction, which is x cannot equal 0. I can reduce or simplify by getting rid of the x's. My final answer will then be 4. Okay? On to problem number 2. Again, we want to look and see if our denominators are the same. In this case, they are x squared plus 5. Now, since we have a subtraction sign, what we're going to do is we're going to change that to addition, and I want to change the sign of both pieces that come after our subtraction sign. So now I can take x minus 3x. Well, x minus 3x would get us negative 2x. I have positive 2 minus 2, which again would be 0. So I'm going to put that over our x squared plus 5. I need to solve my restriction here. So I have x squared plus 5 cannot equal 0. I'm going to subtract 5 from both sides, which would get me, I'm going to draw a little arrow to show you where I'm going, x squared cannot equal negative 5. Now I need to take the square root, so we're moving here. X cannot equal. Now if you remember from first semester, if I take the square root of a negative number, I'm going to end up with plus or minus I. Can I break up 5 at all or take the square root of 5? No, I can't. So it would be plus or minus I root 5. That would be my restriction. X squared plus, or negative 2x over x squared plus 5 is my answer. And we are moving on. Okay? So on to problem 3. Just like on problem 2, I have a subtraction in between. So before I do anything, I want to double check that my denominators are the same. They are. I have y plus 5 and y plus 5. So I'm going to change the subtraction sign to a plus sign. I'm going to make 4y negative. I'm going to make 1 negative. So 3y minus 4y would get me negative y. I have no number in front to add to my negative 1, so I will just have negative 1 all over y plus 5. Before I move on, I need to check for restrictions, so y plus 5 cannot equal 0. That means y cannot equal negative 5. From here, I can double check and see if I can factor it all. The only thing that I could do to factor is take out a GCF of negative 1 in the numerator. But since that really won't get me anywhere, I'm going to go ahead and just say that that is my answer. Okay? On to problem 4. Problem 4, I'm going to go ahead and because my denominators are the same, I can add 2x and 2 together. But since they are not like terms, they will just stay 2x plus 2. I'm going to rewrite my denominator. X squared plus 2x plus 1. Now, I do not have a denominator that will allow me to find a restriction. So what I need to do now is go ahead and check and see if I can factor. Both the numerator and the denominator can be factored. So first I'm going to look at 2x plus 2. It is two terms, so that means it's either going to be the difference of two terms or it's going to be a GCF. In this case, it will be a GCF. If I take out a 2, I'm left with x plus 1 over. How can I factor x squared plus 2x plus 1? It is generic factoring. X squared would turn into x and x. 1 would turn into 1 and 1. Since it needs to add to a positive 2, they will both be positive. Now we're back to problems like we did in our last unit, where I can cancel out anything that is the same in the numerator and denominator. But just like our last unit, before I do that, I need to state my restriction. X plus 1 cannot equal 0, so x cannot equal negative 1. Now that I have my restriction, I can cancel my x plus 1, which means my final answer would be 2 over x plus 1. Okay. On to problem 5. I have a subtraction sign again. When I have a subtraction sign, I want to go ahead and change that to addition, change the sign of my terms. So my x will become negative, my negative 7 becomes positive. So now I can take 2x minus x, which would just get me x. Negative 4 plus 7 would get me positive 3 over x squared minus 3x. It is the same, or plus 3x, I'm sorry. It is the same in both denominators. But again, looking at my denominator, I can factor this. The best way to know whether you can factor it any further or not is, can I find a restriction in my denominator? In this case, I cannot. So x plus 3 over. How can I factor x squared plus 3x? Well, again, it's only two terms, which means that I can take out a GCF here. X plus 3. Now I can find my restrictions. X cannot equal 0. And x plus 3 cannot equal 0. If I subtract 3, I end up with x cannot equal negative 3. Now, just like in our previous unit, I can go ahead and cancel out what matches. Remember that if everything from my numerator goes away, I end up with 1, and that would be over x. So that is my final answer there. On to our last problem, number 6. I have x squared minus 10 plus 3x. Both of those are over the same denominator, x squared minus 4, so I can go ahead and add them. I have x squared. That will not add with 3x. Those are not like terms. So I'm going to end up with x squared. When I add my 3x to my original numerator, my x squared minus 10, I want to make sure that I write that in standard form. So 3x, it will come next. Minus 10 would come last, all over x squared minus 4. I can factor both the numerator and the denominator. So let's look at the numerator first. I do have three terms. It can be factored, so it will be generic factoring. X goes in the first blank. What multiplies to 10 that can add to 3? That would be 5 and 2. Because it needs to be a positive 3, I would have a positive 5 and a negative 2. All over x squared minus 4. Well, x squared minus 4 is the difference of two squares. So I'm going to make two sets of parentheses. The first term is going to be the square root of x squared, which is x. The second part will be the square root of 4, which is 2. 1 needs to be positive, 1 needs to be negative, because I need 2 times 2 to equal negative 4. The only way to make two numbers multiply to a negative number is to have one be positive and one be negative. Before I cancel anything out, make my restrictions. So x cannot equal negative 2, and x cannot equal positive 2. Now that I have factored fully, I found my restrictions, I can go ahead and cancel out x minus 2, which means I'm left with x plus 5 over x plus 2. that is our entire note sheet for today. What you need to remember about this lesson is before I can add or subtract, I need to double check that my denominator is the same. When I add or subtract, I'm combining like terms only. If I have a subtraction sign, I want to change my sign to positive in between, change both the signs of everything else in the second numerator, and I can go ahead and combine them. Once I have combined them, then we are back to our previous unit where I will factor and simplify. Make sure that if you have any questions over this unit or this note sheet that you come in and see me. Otherwise, thank you very much for watching this video and have a great day.